Hello. So move myself out of the way here. Um, the purpose of this video is to look at how to detect collisions. So as part of our unit on interactions, we're looking at how to know when two objects collide with each other. How do we know when two objects interact with each other on the screen by way of colliding with each other? So take a look at this code I've got here. Let me just collapse down the functions first, just so we can sort of see it in a more simple way. I've got two variables, cat and dog, and in my setup function, I draw my canvas and then assign objects to those variables, cat and dog, each object consisting of an x and a y and a size. So you can guess what I might do with those objects in the draw function. I'm going to draw my background and then draw the cat using the variables from the cat object, and draw the dog using the variables from the dog object. So far, this should look pretty familiar. And when I run the code, you see what it looks like over here. Cat at the top, dog at the bottom. Now, the interesting thing comes when we look at the key pressed function. In key pressed, if the key is W, I'm going to change my Y value by -10 on the dog. And if it's S, I'm going to change my Y value by a +10. Take a second to think about what that might do in the program. Yeah, if we're changing the Y value, one of our objects is probably going to be going up and down, and we have just a classic WASD setup here, but without the A or the D, just handling W and S. So let's just open that up and we'll run this again. Click on my sketch to sort of activate it for key press listening, and you can see the dog moves up or the dog can move down. Poor dog, pretty limited, can only move up or down. Now, like I said at the start, the purpose of this is to look at how do we detect a collision? How do we detect that moment when the dog overlaps the cat? Right now, the computer doesn't know when that happens, right? All it's doing is drawing a circle with some x and y in size, another circle with an x and y in a size. It's not keeping track of whether they're overlapping or not. And so we have to write the code to check for that. And believe it or not, you already know the pieces that you need for the most part in order to do that. So if you feel like you want to give this a shot on your own, why don't you pause the video right now and tinker with it. See if you can figure out a way for the computer to know whether these two objects are overlapping or not. Okay, if you're still with me, that means that you're going to follow along with me. Now, here we are. That's good. That's why I made the video, right? I mean, if everybody could just go off and do it, no reason to have a video. So what we're going to use in this is I wonder if I can do some good pen work here. Yeah, so we're going to use the distance from the center of one circle to the center of the other circle as our like key indicator of how close these two circles are to each other, right? Because if they're really, really close, they're probably overlapping. If they're really far away, they're probably not overlapping. So we're going to, this is a key element for us. I shouldn't even bother trying to write out all of distance, right? And we'll just call it dist. Distance between the centers of the two circles. Now we can write the code to do that by, well, I mean, you could do a little bit of math on the x and y's and maybe a Pythagorean theorem. When they're at an angle, you're going to get the hypotenuse, and P5 saves the day. Computers probably have a built-in function to handle these things for you, and in fact, P5 does. It's called the dist function, and here's how it works. I can take, let's I'm going to make a local variable. That's a variable that I declare and set right inside here. So we'll say let distance get dist is the function, and notice it turns bold there, which is an indicator that I probably have written something that's built in. And then I just need to give it 4 values. The first two are the xy coordinates of the first point that I want the distance from, and then the second 2 values are the xy coordinates of the last point that I want the distance from. And so this will give me the distance between 2 points in pixels. The unit is pixels here, right? Everything we're doing here is pixels, right? The x and the y are all pixels, size is pixels, and everything like that. So what is the x, y coordinates of the first point that I'm interested in. Well, let's do the cat as our first point. And look at this. I have the x and y values are ready for the cat right there um, to draw the circle. So we'll put those there. And then same thing for the, let's move this over some here. Same thing for the second point of my distance. So we can do dog x, dog y. Now, the distance variable will hold the distance in pixels between the center of these two circles, and we can check that by putting let's just print some text to the screen with that distance in it. So we can just print the distance down at the bottom of the screen, like 200. Y value would be down at like 380. Let's do text align center to put in the center, and text size so we can read it. Text size at like 20. Okay, let's see what this does. Whoa, that wasn't right. Let's do this again. Here we go. And we gotta erase the screen. And it's hidden below the dog there. But you can see now that variable is giving me that value down at the bottom here, right here, is giving me the distance between these two objects as they get closer and closer. And then the centers will end up on top of each other right there, right? And here the centers are really far away from each other. So what are the point we're really interested in is this point right here where they collide. What's the distance when what's the distance between the centers when the two objects bounce up against each other? That's really what we're interested in. And so let's take a look at how we can find that. I'm going to turn on my trusty pen again. And notice each of these are circles, right? And so I've got a radius to my circle here and another radius on this circle, which is right there. And take a second to think about how this collision point can be represented by using the radii of the two circles. Now, let me draw these again slightly differently. Here's the radius of one circle. Here's the radius of the other circle. So if the distance between, look at this is looking like my distance diagram, right? If the distance from here to here is the same as or less than the two radii put together, then we can say that the objects have collided. And so do we know the radii of these two objects? In fact, we do. Right? It's the, well, we're kind of representing it right here with the size. Now, here's the thing. The size, I called it size in this sketch. In previous sketches, you've seen that we call this also diameter. So this is the diameter of the circle for the cat, the diameter of the circle for the dog, and the diameter is actually two radii put together, right? And so what we're going to be comparing this to is actually half the size of the cat and half the size of the dog. So our actual distance, let's call this actual distance now. Actual distance is that. Actual distance. And then let's make another variable, which is our collision distance. What's the point at which they're considered colliding? And so we can say let collision distance get. And how do we get this? This would be the radius of the cat. Well, so that's the diameter. So that's the radius of the cat. Cat size divided by 2 plus dog size divided by 2. So that's the radius of the dog. Put the radius of those two together, and that's the point at which they're colliding. And let's just check this down here at the bottom. We can say actual. All right, here's how we print the actual distance, and let's raise it up just a little bit. And we'll put the collision distance here so that we can keep track of what that is as well. Move that down a touch. All right, let's see what we've got now. And, dog's in the way again. Oh, come on, dog. Here we go. So the actual distance between the two centers is there. And this here is our collision distance. That's what we're going to call our threshold for when they collide. So let's see, 130, they're almost collided. 120, yes, that's a collision. And look at that. An overlap would be when actual is less than the collision distance. Okay. So let's make use of this. You've seen greater than or less than comparisons before. Notice that's what we just did here is a less than comparison. And so think back to where you've seen that before and what kind of code you used when you were comparing whether one value is less than another value. I hope you're thinking about if statements, right? So we did an if statement in the past where you can do like if something is true, then inside these curly braces, I'm going to write some code in here that I want to run if that thing is true. So here's my block of code that's going to run if whatever in here is true. So the sort of the magic thing we're looking for here, right, is if the actual distance is less than or equal to the collision distance. That's true. They can be said to have collided, right? And so what do we want to have happen if they collide? Let's let's change the color of the cat. The cat can turn red when they collide. So I can't quite just do like fill 255,0,0, right? Because that's going to get overridden by this fill next time I draw the cat. So we can just see this here, right? There we go. Dog's going up. Collision. Nothing happened. This fill was overridden by this here. So instead of doing this calculation here, let's move all this stuff up to the top. Not just that. Before the cat is actually drawn, then we can use this to help us draw the cat. So here we go. We have our regular distance calculations. This is all fine. And then if our actual distance is less than our collision distance, then we use a red. And then let's just do another if statement. If actual distance, whoops, no space there, distance is greater than collision distance, then we'll just go with our classic tabby cat color of orange here. Okay, add a little code here, and this will be change cat color on collision. Let's run this. So we're checking for our collision, checking our collision parameters here. And then we're going to see if we've collided, our fill color will be red. If we haven't collided, our fill color will be orange. We'll use that fill color to draw the cat, and then we'll just get a new fill to draw the dog. Let's run this and see how it goes. So there we go. We're watching the comparison between the actual and collision values. Bam! Yes, look at that. And you can leave the collision, right? And the value changes again there. Nice. So that's a basic approach to doing collision detection using the sizes of the shapes that you're interested in. One small little like bonus thing I'm going to throw into this video here is this. Do you notice that this felt a little awkward? I'm kind of like repeating like if less than or equal to, we'll do that. If greater than, we'll do that. This is like a lot of repetition on this code to write all that again. And so I want to show you a little bit of a shortcut. It's always going to be either or. This is collide, and this is didn't. Right? It's always an either or. It's going to be one or the other every time. And so we can shorten this if expression by doing what's called an if-else statement. So if it collided, we'll do this. Else means in all other cases. Otherwise, we do this. So the else is a handy thing. We don't have to rewrite this whole thing again and do it backwards. Okay, let's just run this one more time because this is a lot of fun. There goes our dog. Collision detected. No longer detected. All right, enjoy your coding.